our previous exercise, we learned the operation sequence and the safety of this particular design. Now we're going to simulate the system now. Then if any error is found, we'll now fix it up before we now implement the practical aspect of it by building the panel and putting up the layout of the component in an enclosure, get it ready for implementation. Okay, let's simulate and see if we can find any error from the system. Okay, all right, I put on the system now. Like I said before, these two contactors will close simultaneously. Okay, let me see if I can uh, increase the changeover interval, the time at which the star and delta contactors swap their operation. Let me increase this to be, make it to be 50 seconds to enable me walk you through the operation sequence. All right, now let's simulate again. I just increased the time, the preset time between the star and the delta contactor transition time. Okay, let's simulate again. Okay, now this one will illuminate. This one, once you put on the system, this one will indicate that the star has energized, the star contactor is in energized state. Then this one also is also taking care of this one. This one is for the line contactor. It also illuminate, telling you that the line contactor is in energized state. Then once this one comes up, this one also come up. So this 1, 2, 3 will indicate whichever, whenever these contactors come active. That is the work of these indicator lamps. Then in terms of fault, and this one trip, this is a fault lamp that will come up showing that the system is de-energized, right? Okay, so after troubleshooting and you reset the overload, you now come and reset this and you now put on the system again. Like I said before, this is my safety device. I made mention about these design safety features: phase sequence, phase failure, and voltage monitor. I told you about 5% acceptable voltage drop limit that motor will work with. That is 5% of the declared voltage range. So this is the device set aside to monitor that 5%. Like I say, 5%, that means motor is going to work within 400 volts to 380 volts. So 380 to 400 it is acceptable voltage drop limit for induction motor to work safely and efficiently. Okay, so this one has energized. Okay, the changeover has taken place now. Remember, I increased this to enable you see the fixtures of the parameters. Okay, now, if the system is working and along the line and there is a fault from the prime mover, that is from the mechanical part of the system, because the work of this particular overload is to protect the motor from preventing the motor from the fault which may arise from the mechanical part. For example, if there is a friction or resistance from the impeller, from the shaft, from the pump, any of the bearings is gotten or stuck or stiff, these are what can make the temperature of the motor to rise, and the current will also get excessive range. So because of that, there is a device called overload to prevent the motor from getting damage from that mechanical part. So that is the function of this particular overload. Okay, in terms of fault, and the fault is coming from the mechanical side of the equipment, this particular device will trigger, will trip off. So let's see if we can trip it now. And now put it on. I trip it. So the entire system has shut down, and this lamp just is now telling me now there is a fault. So that is the function of this lamp, to illuminate, telling me that the system is in a shut down state and there is a fault within the system. So we now come and carry out the fault finding after troubleshooting and rectify and fix the issue. We now come to reset the overload. While the fault is still in active state, this particular overload cannot be reset. Even if you reset it and put it up again, it will also shut down again. So you must troubleshoot and find out and fix the fault before coming back to energize the system again. It can also be resetted. After resetted, you now go and troubleshoot and rectify the fault, but you cannot energize it again without troubleshooting and find out the fault. All right, these are the system put in place to safeguard and monitor and um, the situation and the status of this particular motor. Okay, let's see if I can reduce the. Okay, let's walk through here again. I put it on again. This one is up. This one is up. My voltage monitor phase failure and voltage phase sequence is also monitoring the system, that is this particular device. All right. Now take a look at this. This is K1 star contactor. This is K2 mains contactor. They are getting energized now, and this one is counting. The counter is counting. This is delta. By the time these two take over, these two changes. I mean, these two changes, and this that is when this one elapses. These two will now change over, and it will also reflect here. That is how you monitor the simulation. Okay. Now let me shut down from here. Shut down from here. Now let me put it on again and show you one other safety. Oh, sorry, my keyboard is disturbing. Okay. Now, if the motor is running and there's an emergency within the system. This also another device called e-stop emergency push button. You can also use this to shut down the system. Can we try it now? Okay, the system is shut down. So you can either shut down from here or you shut down from here. Why this one is very necessary is that some enclosure, some panel, when you put on the panel, they will lock it up. There are some enclosure that you must open the enclosure to gain access to the off on button. So whereby there's a problem and the particular key to unlock the closure is not accessible that particular moment. While looking for the key, the damage will also get excessive. So before then, you can now push this emergency push button because the provision of this must be outside the enclosure. Where this particular device is going to be situated must be outside the enclosure, outside the panel. So it's accessible anywhere, whenever you want it. But some enclosure will be designed such that you open the panel first before you gain access to the push button. So because of that, there is additional shutdown device called emergency push button that must be located outside the enclosure. So without opening the panel to shut down, you can access this and shut down the system. All right. So let's try once more. Let me now reduce the changeover time, and then we'll now monitor the more. The default setting should be 3 seconds, depending on your efficiency of the motor. So let's try once more. After this time, I put on the system. This to get energized first. When the time elapses, this one de-energized and this one gets energized. So the motor will now work in, will be now subjected to high speed, and the normal um, efficiency will take over. All right, I want to shut down from here. So in our next exercise, we now learn how to design this and how to design this as well. All right, thank you.